This video is on dimension analysis. So why dimension analysis? What is dimension in physics? Dimension is the expression of a derived quantity in terms of the basic fundamental quantities. For you to write dimension correctly, there are a few things for you to know and you must review. For you to write dimension correctly, you must know the difference between fundamental and derived quantity. Then you must be able to apply some laws of indices. So what are fundamental quantities? Fundamental quantities, they are independent quantities. We have about 7 of them, but 3 are basic. The basic fundamental quantities are mass, length, and time. And this is what dimension employs. So the dimension for mass is uppercase M, dimension for length is capital L, and dimension for time is T. So dimension is written in MLT form. Then again, you must know the laws of indices for you to write dimension correctly. At least 3 basic laws of indices. Understand that a to the power of n multiplied by a to the power of m in indices is a to the power of n plus n. For example, a to the power of 5 times a to the power of 3 is equal to the a to the power of 5 plus 3, which is a to the power of 8. That's the first law. If you have a to the power of n divide a to the power of m, this is equal to a to the power of n minus m. Again, example, a to the power of 5 divide a to the power of 3 is equal to a to the power of 5 minus 3, which is a to the power of 2. Then thirdly, if you have a to the power of 1 over n is equal to a to the power of negative n. So a to the power of 1 over 2 is a to the power of minus 2. So if you have all those well understood, you'll be able to write correct dimensions correctly. Let's take some examples so that we can know how to write dimension. Now, for you to write dimension of any quantity, you must know the formula connecting that quantity with its basic fundamental quantity. For instance, let's take velocity as the first one. Dimension for velocity can only be written if we know the formula for velocity. The formula for velocity is displacement over time. So if velocity is displacement over time, what is the dimension for displacement? The displacement is distance in a specific direction. The dimension for displacement will be L, and dimension for time will be T. Putting it together, dimension for velocity is going to equal LT to the power of minus 1. So that is the dimension for velocity. Number 2, dimension for acceleration. As I said before, for you to write dimension correctly, you must know the formula for that quantity. So what is the formula for acceleration? Acceleration is velocity over time. So if acceleration is velocity over time, what is the dimension for velocity? Dimension for velocity is LT to the power of minus 1. Then over time, dimension for time is T. Put that together, we have LT to the power of minus 1 minus 1, which is equal to LT to the power of negative 2. Minus 1 is negative 2. So dimension for acceleration is equal to LT to the power of minus 2. Right? Number 3, dimension for force. What is the dimension for force? We can only write dimension for force if we know the formula for force. The formula for force is mass times acceleration. So what is the dimension for mass? Dimension for mass is capital M. Acceleration is velocity over time, which is going to equal to LT to the power of minus 1. Dimension of velocity is LT to the power of minus 1. Displacement over time. Acceleration is velocity over time. So put that together, we have MLT to the power of minus 1, which is equal to MLT to the power of negative 2. So dimension for force is equal to MLT to the power of negative 2. Number 4, density. You can feel free to pause the video and solve number 4 before we do look at it together. Density. What is the formula for density? Formula for density is mass over volume. So if it is mass over volume, what's the dimension for mass? Dimension for mass is capital M. Dimension for volume is L to the third power, because volume is length times breadth times height. So length and breadth and height all have a dimension for length. So length times breadth times height is going to give us L to the third power. Then put everything together, dimension for density is equal to ml to the power of -3. That is the dimension for density. Going forward, next one is work done. Work done and energy have the same dimension. That is why we put them together. So what is the formula for work done? The formula for work done is force times distance. Force times distance is the formula for work done. So what is the dimension for force? Let's say in exam condition, if you have not done dimension for force before, you can take it from scratch. Dimension for force is going to be obtained by its formula. Formula for force is mass times acceleration. So work done is going to be mass times acceleration times distance. What is the dimension for mass? Dimension for mass is capital M. Dimension for acceleration, since acceleration is velocity over time, or from its unit, meters per second squared, dimension for acceleration is going to be LT to the power of -2, and multiplied by distance. Dimension for distance is L. Put everything together, we have L times L is going to be L squared, and T to the power of -2. This will be the dimension for work done for energy. So dimension for work done in energy is ml squared T to the power of -2. Number 7, power. So what will be the dimension for power? First, we need to know the formula for power. Formula for power is work done over time. So power is rate of doing work done over time. What is work done? Work done is force times distance. So power is going to be force times distance over time. Dimension for force is mass times acceleration, that is mlt to the power of -2. Dimension for distance is L, then over T. Combine everything using law of indices. We have ml squared T to the power of -3. So dimension for power is ml squared T to the power of -3. Number 8, momentum is another example for you. Momentum. For us to do dimension of momentum, we first need to know the formula for momentum. So formula for momentum is mass times velocity. So momentum is the product of mass and velocity. Dimension for mass is capital M. Dimension for velocity, since velocity is displacement over time, that is going to be L over T. So put it together, we have mlt power of -1. -1. That will be the dimension for momentum. Number 9, moment. Moment as a physical quantity in physics is obtained by the product of force and perpendicular distance. Right? Moment and work done, we have the same dimension, but ideally, moment is different from work done. Right? That perpendicular distance shows that direction is important in moment, which makes moment a vector quantity, while work done is scalar quantity. The dimension for force, since force is mass times acceleration times perpendicular distance, the dimension for mass is capital M. Dimension for acceleration is LT to the power of -2. Dimension for distance is L. Put that together, we have ml squared T to the power of -2. That's the dimension for moment. So moment and work done they have the same dimension. The last one, coefficient of viscosity. Coefficient of viscosity. First, we have to know the formula of coefficient of viscosity, of course. But the formula we are going to use is the formula connecting viscous force and coefficient of viscosity, which is viscous force or drag force in liquid is equal to coefficient of viscosity multiplied by area multiplied by velocity gradient. So velocity gradient is different from velocity. Make coefficient of viscosity subject of formula. Coefficient of viscosity is going to equal viscous force over area multiplied by velocity gradient. Dimension for force is, since force is mass times acceleration, that is going to equal mlt to the power of minus 2. Dimension for area, since area is length times breadth, dimension for area is L squared. Dimension for velocity gradient is velocity over length. So that is going to equal Lt to the power of -1 over L. Dimension for velocity gradient is equal to, since L cancel L, we have T to the power of -1. Putting it together, dimension for coefficient of viscosity is going to equal to mLt to the power of -2 over velocity, dimension for area is L squared over L squared multiplied by T to the power of -1. So we have mL to the power of 1, since it's divided by L squared, that is going to equal to -2. Then T to the power of -2 minus -1, because this is division. So we have mL to the power of -1 minus 1 minus 2 is -1. Then T to the power of -2 plus 1. So we're gonna get L to the power of -1, T to the power of -1. That's the dimension for coefficient. So that is how you do dimension, right? If anything you didn't get, you can rewind, go back, and then practice again. Now, so why do we do dimension? Dimension is done to check the correctness of an equation. If you have an equation and you want to check if the equation is correct, you can use dimension. If you have a formula that says v squared equals to u squared plus 2as, you can use dimension to check if this is correct. Then also dimension is done to check the dependence of that physical quantity on the basic fundamental quantity. For instance, all the examples that we did so far, force, we can see that this dimension of force is mLt to the power of -2. We can see that the basic quantities that we have in force are mass, length, and time, and they are combined using this ratio, or they are combined this way. That is, force is dependent on mass, it's dependent on length, and it's dependent on time according to this proportion. So that is why we do dimension.